All right, here we are in 9.1, central and inscribed angles. Okay, so we'll talk more about central and inscribed angles, but first it's important to know the vocabulary that we'll be using. So, for example, first thing up here is the circle. Okay, a circle is defined by all points, put those backwards, all points on a circle are equal distance, means that they have the same distance, okay, from the center point. So any point on a circle, so for example, if this was our circle, we'd know that a point from the center to any point on the circle, they all have the same distances, okay? And that's called the radius, and we'll talk about the radius, okay? Diameter, the diameter is a line segment. So the difference between a line and a line segment is a line, oftentimes when we have like a graph, a line segment, or a line, sorry, goes to infinity, okay? A line segment, so this would be a line segment is something that starts and ends, has endpoints. So this would be a segment, okay? So a diameter is a line segment that connects 2 points on a circle and through the center, okay? So for example, here that would be BE, okay? And how we write that is with just a bar on the top. That means it's a segment, the segment BE, okay? And that's the only diameter on this picture, all right? With endpoints, or not endpoints, circles, we write it as a circle with a dot with the center and its letter. So since the center is C, we'll just write it as circle with a center of C. Okay? Radius, let me just erase some of this stuff. The radius, we will write that as a line segment connecting the center and any point on the circle. So on this graph, we have 3 radii. We could write it as CB, we could write it as CE, or we could write the radius as CD. So we have 3 radii. Okay, a chord is a line segment connecting any 2 points on the circle. So a chord is basically the same thing. Well, it's okay, kind of like a diameter, but the diameter for a chord, it doesn't have to go through the center. So AF is a chord, and BE is also a chord. Okay? So circle, diameter, radius, and chord. So like a radius is not a chord because it doesn't have 2 endpoints that are on the circle. All right, so these are some things that I asked the students to do. I would suggest pausing and doing that, and then making sure you did it right. Okay, hopefully you did that. Here we go. So name of a circle. So just like we did for the circle at the very top, we do a circle with a center, and we write the letter of the center. So for this one, it would be L. Name the radius of the circle. So this one, we actually have 5 radii. We could do LG, we could do LH, we could do LI, we could do LJ, and we can do LK. Name a chord on the circle. So here we have 2. Remember, a chord is a line segment that connects 2 points on the circle, so we could do HI. And we could also do the diameter, which is GJ. Okay, and again, the name of the diameter would be GJ. And then we want to answer these 2 parts. E. So if GL, let me mark that down, GL right here, if that is 10, what is JL? So that would be right here. So what would this length be? Okay, since they're both radii, we would know that it would also be 10. Okay, so let's answer the next question. JG, so JG is the diameter. What is LG? So this was want to find this part. So it would be half of that, 7 divided by 2, or 3.5. Right? And then the last one, if LK, right there, is 4.2, what is HL? So again, these are both radius. Okay, so this is also 4.2. Okay, hopefully that helped, or at least understand. This is just a quick review or a discussion of a circle and how to find the circle, diameter, radius, and chord. Okay, so this is the meat of what we're covering today is central angle and inscribed angle. Okay, so a central angle is an angle, oh, I think I wrote that wrong. An angle, I think I was supposed to cross that out. An angle where the vertex, sorry, getting this a little off. An angle where its vertex is at the center and endpoints on the circle. So for example, if we look at this right here, this would be our vertex right here, and it's at the center and has its endpoints. So there's one endpoint and here's another endpoint that's on the circle. So this would be a central angle. Okay, we'll learn about other types of angles, but with central angles, there's something special about them. So this is the angle right here. Angle. And there's something else that we'll be talking about a lot is the arc. So this is an arc. All right? And if we have a central angle, the angle is equivalent to the arc. All right, but it's only when you are doing or using a central angle. Okay? So you'll have other types of angles and that won't apply. This is only when you're doing central angles. Okay? So for example, let's say this angle is 110. The arc would also be 110 degrees. Okay? All right, so there are different types of arcs. There's minor arcs, major arcs, and semicircles. Okay? Minor arcs, so here they give you an angle of 110. The minor arc is an arc where it is less than 180 degrees. Okay? So for example, this one, the minor arc here would be 110 degrees. Okay, they're equal. Okay, major arc is when the arc is greater than 180 degrees. And I've had a lot of students get a little confused at the start because here what we're looking for is the major arcs. Sometimes they think that this is what we're looking for and they say, well, that's not greater than 180 degrees, and that's correct. The major arc for this circle would be this. Okay? The other part, this would be a minor arc. All right? So we're looking for the major arc. And if we remember that a circle is equals to 380 degrees, we can figure out what the major arc is by doing 360 degrees, for that's the whole circle, and we would just subtract the minor arc, which is 60 degrees. So the total here would be 300 degrees for this major arc. And then semicircle, when you have a semicircle, we have basically two halves. Okay, we'll be looking at that one. Okay, And the semicircle will always be equal to 180 degrees. All right, so this would be 180 degrees. All right, so let's fill in some of these things. So names, like when we write down up here, we wrote down the name of a circle, how to name a radius or a chord or a diameter. On all of these segments, we just put a line on the top, okay? If you were to do, just FYI, if you wanted to do a line, something like G, J, or something that was a line, you would have these arrows that would go to tell us that it's going for infinity. Anyways, that's a little interesting, I guess, okay? So for an arc, for example, this one, the arc for this minor arc, it would be AC, and we would put an arc sign kind of thing on the top, a little curved line like it was part of a circle, okay? For a major arc, this one we said it is 300 degrees, okay? So this one will maybe start at D, and then sometimes people suggest, well, maybe DF, okay? But when we have two choices, if you wrote it like this, we wouldn't be able to tell if we're talking about the minor arc or the major arc. So to fix that, oftentimes we'll put a little point where we want it, what we're looking for, and we would write it as DEF, okay? And that would tell us that we're going to start at D, and we're going to follow the circle through E, and then we continue all the way to F, okay? And that's how we define this major arc. Okay, semicircle, do the same thing because we don't know. If you said the arc JL, we wouldn't know if we were doing which side of the semicircle. So we would need to write it as JKL. Okay? And then here we've already really done this one, arc degree. Arc degree for this one would be 110. Here the arc degree would be 300 degrees. And then the last one would be 180 degrees. Okay? So that's pretty much the gist of central angles. So let's go do a few examples. In class, I asked you guys to do A, B, C, and D. Although I did A for everyone so that they could get started. So we have a circle F. The measure of DFE, which is right here, is $50 degrees. And we have CF and FB are perpendicular, so we know that this is 90 degrees. Okay, so whenever we have this little box in the corner where the angle is, that means it's this 90 degrees. Okay, so they want us to find what is the measure of the arc AE or EA, something like this. Okay, so whenever you do these problems, there's oftentimes multiple ways to do it. Okay, so one way I've had people say, well, let's just finish in all of these spots and then we'll subtract that all from 360 and that will give us this part. Another thing you could do it is you could say, well, this right here is a diameter, which tells us that the arc DAE is equal to 180 degrees. So if we go from here all the way over here, that gives us 180 degrees. It's a semicircle. Okay, and since they give us 50 degrees, the arc here would be 50 degrees. And if we want to find the arc AE, all we need to do is 180 degrees minus 50 degrees gives us 130 degrees. Okay, so here we'd say this is equal to 130 degrees. All right, so if you can pause, see if you can come up with how to do the rest of them, and then come back to me and we'll see what we can come up with, okay? All right, hopefully you did that. Let's see what we've got. So we want to find the arc CD, so this small part right here, okay? So if we realize that this is 90 degrees, and this is 50 degrees, and this is a semicircle, which is 180 degrees, we can just say, we can go 180 minus 50 and minus 90. And that would leave us with 40 degrees. Okay? Okay, next one. They want us to find out what the arc ACE is. So we'll go A to C to E. So there's a couple ways you could come up with this. We already proved or found that this is 130. So one way we could do it, we could do 360 minus 130, and that gives us 230 degrees. Okay, so that would be one way you could do it. Another way you could do it is we already know that this is 40 degrees. We know that this is 90 degrees. Okay, this is a semicircle, so this also has to be 50 degrees. So you could just add all those up and you would get the same thing. Okay, last thing, find the arc that is congruent, so two arcs that are equal with AD. So here's one. This is the one we want to find that's the same, congruent. And we already just found out that this is 50 as well. So the arc that we're looking for is arc BE. All right? Okay, next. These ones will be a lot like what will be on the test for central angles. Okay, so here what we know about central angles is that the arc is equal to the angle. So for this, we would know that this arc is 112 degrees. Okay, this one, we know here that we want to find this angle. Okay, so again, we know that the arc is equal to the angle, so we know that this is also 61 degrees. And this is a semicircle, which is 180. So if we want to find this angle, all we need to do is 180 minus 61, which gives us 119 degrees. So that would be your answer for that. Okay, again, this is basically the same as we did for A. We know that the arc is the same as the angle, so this would also be 130 degrees. And then D, finally, this is a diameter. So we know that this arc is 180. And what they want is what is F, D, E. So all we need to do is do 180 plus 95, and that gives us the whole thing would be 275. Okay, degrees. Okay, then we have these ones that are a little different, basically one step extra. So here we want us to find this angle, the angle FHE. Okay, but they give us that the angle is this and that the arc is equal to this. But we know the arc, when we have a central angle, which we do, the vertex is at the center, we can say that the arc is equal to the angle. So we'll say 11x minus 1 is equal to 9x plus 11. Okay, so now we just need to solve for x, plus 1, that cancels, and then we'll do subtract 9x, and we end up getting 2x equals 12. And then divide both sides by 2. That cancels, and we get x equals 6. And we're not done, because we want to find what the angle is. We don't just want to know what x is. So we'll just substitute this in, x equals 6. So we'll get 11 times 6 minus 1 gives us, this would be 66 minus 1, or 65 degrees. Okay, well, that looks about right. Okay, here's another one. If you can, please pause and do the rest of them. So they want us to find JK, the arc JK, which is right here. Okay, and we need to find the x's first, be able to find what that is, but at first it's a little different than what we have over here. Okay, but if we realize that for a circle, all of the angles add up to 360 degrees. So we're going to use that to solve. Okay, so here we have these 3 arcs, okay, and we already know that all the arcs are equal to the angles as well. Okay, so all we need to do is say, well, if we add this arc, we'll get x plus 129, and then we're going to add that to this arc, which is, we'll add a negative 8x plus 13, and then we're going to add this arc, and we're going to equal that all to 360 degrees. Okay, so the angles for a circle is 360 degrees, and all of the arcs, if you add them together, it's also 360 degrees. Okay, because for central angles, we know that the arc is equal to the angles. So we'll combine like terms. So we'll maybe, I guess not that, we'll subtract 129 from both sides. We'll subtract 13 from both sides, and we'll subtract 2 from both sides. And then we'll just combine these like terms. So you add those together, we end up getting 24x, or negative 24x equals to, and you'd probably want to have your calculator, and that adds up to give us 216. All you need to do to get the x by itself now is to divide both sides by 24, and we get x equals negative 9. Okay, so now we have x, and we want to find the arc JK. All we need to do is plug that in for x, and we get negative 8 times a negative 9 plus 13, and that gives us 85 degrees. Right? So that's just a little algebra, just plugging things in, moving things around. Shouldn't be too bad. Okay, here's another one. Again, pause if you haven't done this yet. It will help you the most. Okay, we want to find IH, the arc IH, which is this part. Again, you're going to use the same thing. A circle adds up to give us 360. Okay, so we could say that this angle is also x plus 130. Okay, so we'll add all that together. We'll do 130 degrees minus 21x plus x plus 130. So here's like one part, here's the other part, and here's the last part. That all adds up to give us 360 degrees. Combine like terms, so this is like terms. That will give us negative 20x, and then we'll subtract 130, and we'll subtract 130 from both sides. Okay, so that gives us equals to 100, and then we'll just divide both sides by negative 20, and we get x equals negative 5. Okay, and now all we need to find is this arc. So we plug that in we'll get -5 plus 130 equals 125 degrees. And that's your answer. Okay? Again, pause please and see if you can get this problem. This time we're looking for the arc LM. Okay? So, one thing we can realize here is that this arc is also this angle, and this arc is the same as this angle. Okay, and these two angles are congruent. Okay, so we can just set them equal to each other. 3 plus 11x equals -4 plus 12x. Okay, we'll solve for x. We'll add 5 to both sides, and we'll subtract 11x from both sides. That cancels. Oops. This should be 4. My bad. Okay, so we'll end up getting x equals 7, and then we will plug that into our equation. So this is the one we're looking for. We'll plug that in, we'll get -4 plus 12 times 7, okay, and 12 times 7, this is -4 plus 84, which gives us 80. So this would be 80 degrees. Okay, so hopefully you feel comfortable, at least after you've done your homework, that you feel good that you can do central angles. Okay, and we have one more thing, is inscribed angles. All right, an inscribed angle is an angle formed by two chords. So if we look at this, we have these two chords, AB and CB, okay, formed by two chords in a circle which has one common endpoint. So our endpoint that's in common would be our B. Okay, and the vertex and the other endpoints are all on the circle. So A, B, and C are all on the circle. So central angles, the vertex is on the center, thus central angle, and for inscribed angles, the vertex is on the circle as well. All right? And the rule for inscribed angles is that the angle is equal to 1/2 the arc. Or vice versa, you can also rewrite this as the arc is equal to 2 times the angle. And let me prove that to you. Okay, I mean, this isn't something that will be on the test, but it's interesting to know that's how it works. Okay, so if we were to take this and put another chord that goes from B to some other point, let's say E, okay, and let's say that this angle is 10 degrees, okay, it could be anything, okay, but let's say 10 degrees, okay, we can write another radii that goes from the center to C, and since these are both radius, they have the same distance or the same length, then that means that this is an isosceles triangle, which means that this angle is also 10 degrees. And triangles add up to give us 180, which means that this angle is equal to 160 degrees. Okay, so there's something we've gotten so far, an isosceles triangle. Okay, but we also know that this angle right here and the 160, those are supplementary. That means you add them together, that gives us 180. Okay, which makes sense. It's a semicircle, which makes sense. So this would be 20 degrees. And we just proved also that the angle is the same thing as the arc. So this arc right here would be 20 degrees as well. So if you compare this 10 degrees to the arc, the difference is you just multiply the angle to give you what the arc is for an inscribed angle, okay? And then you can do the same thing with this other part. You could say this is 9 or something. You would still need to find this. This would also be 9 degrees because these are the same. And then this angle would be something like 162. This part right here, because it's a supplementary angle, we would know that this part would be 18, and then this would also be 18. Okay, so from there you could add those all together. This original angle right here would be 19, and the arc, when you add those together, that would give us 38 degrees. Okay, and there again, you can take the arc, or the angle, which is 90 degrees, multiply that by 2, and it gives us 38 degrees. Okay, so that's kind of cool, and that's the way you come up and can prove that this equation is valid. Okay, but from here on, from all of these problems, you can just assume that that is true. Okay, you don't have to go through that process every time or anything. You're just going to use what is given. Okay, the angle is 1/2 the arc, and the arc is 2 times the angle. All right, so this is a special case where the 2 endpoints here are also can include the diameter. So the endpoints, the 2 endpoints are part of the diameter. In this case, use the same equation, but what you find here is that this is like 180 degrees, this is 90. Okay, and so from that we can find that the arc for this one, the arc is 180 and the angle is 90 degrees. Okay, so I'm just making a video. You're welcome to go ahead and do that. Okay. Okay, so here what we're going to do is we'll see if we can come up with these problems. So just remember, they gave us the arc here. We are going to use the equation of, we want to find the angle is equal to 1/2 the arc. So here we just divide that by 2, and that would give us, half of that is 87. Okay. The next one, B, we'll look at B. They give us the angle of 50 degrees. The arc will always be connecting those 2 endpoints. Okay, so this right here is our arc. To find that arc, the arc is 2 times the angle. So here that would give us 100 degrees. And then we realize that this is a semicircle, adds up to 180 degrees. So this question mark would be 180 degrees minus 100, or 80 degrees. Okay? Let's do some of these other ones. Okay, so whenever you have a problem like this, if they give you an angle, I would suggest writing down what the arc is. So again, those are our 2 endpoints that make up our arc. This will be, the arc will be 2 times the angle, which here would be 2 times 39 degrees, gives us 78 degrees. Again, this is a diameter, so this whole arc is 180 degrees, meaning that the question mark is equal to 180 degrees minus 78, which is 102 degrees. Okay, so feel free to, sorry, I should have said this again before, always pause if there's problems to work on, so if you can see if you can do it by yourself, you'll learn so much faster. Okay, and then D, so pause this if you haven't done it already. All right, here we have a diameter, okay? Which means that this whole part is equal to 180, but they gave us part of it already, which is 96, so that means that this part of your arc is 180 degrees minus 96 degrees, which is 84 degrees. So this is 84 degrees. Okay, so this would be our arc, and we'd want to find the angle. So this is also an inscribed angle that we're looking for. So all we need to do is do 84 divided by 2, which gives us 42 degrees. All right, again, there are different ways that you can come up with the same solution. So if you found a different way, but you got the right answer, that is just fine. I'm not looking for a specific way to find it, as long as you are, showing your work and coming up with the right answer. Okay? And then we have a couple others that include the variable that's inside of it. So here they want here to find this angle, ZKY. ZKY. All right. So here we're going to have to use the equation, something to do with your angle and your arc for an inscribed angle, because here's the angle. This is the angle that they give you, and this is the arc, and there's a relationship between those two, okay? And that relationship is angle equals 1/2 the arc. You could also use it the other way, where it is the arc equals 2 times the angle. Either way, you'll end up getting the same value. So let's do the arc one. So arc is 4x plus 16 equals 2 times the angle. Okay, we would distribute that to that is 38. Okay, and then you would just want to combine like terms. So maybe subtract 2x, and then subtract, that cancels, subtract 16 from both sides, and we'd get 2x equals 22, right? Yes, okay. And then we'll just divide both sides by 2, and we end up getting x equals 11. Okay, and what they want is the angle, so we will plug that into our angle, and would get 11 plus 16, which gives us 30 degrees. Okay, if you use this equation, you end up getting the same thing. Okay, and then finally, they want us to find what the measure of MKL. So here, MK is a diameter, which means that this whole part adds up to give us 180 degrees. So we can use that and say 13x plus 1 and add that to 21 plus 9. Those two arcs should add up to give us 180 degrees. Okay, so we will just combine like terms. Sorry, I messed that. There should be an x there. Okay, so add those together. That should give us 34x. And then we'll subtract 1 and subtract 9 from both sides. That gives us a negative 10. Gives us 170. And then we'll just subtract both sides by 34. And we get x equals 5. Okay, let me double check. 170 divided by 34. Yes, okay, so that would be our x. And what we want is this angle. Okay, so maybe we'd want to find this arc. So if we find this arc, then we can find the corresponding angle that we're looking for. So we would plug that in. That would give us 21 times 5 plus 9, which is equal to 114 degrees. And so this would be 114 degrees. Okay, and then to find that angle, we know that the angle is half of the arc. So 114 divided by 2, that gives us 57. And that would be your answer. Okay, so there's lots of examples that you can do for your homework. Okay, so make sure, and the homework has 3 pages, don't forget, on the bottom, or the bottom it always says like 1/3 or 1 out of 2 or 1 out of 3. This one's out of 3. So make sure you do all 3 pages. Okay, all right, thank you for your time.